In today's video, I'll be sharing how to create a spiral that you can keep adding points to the end. We'll also be trimming it with a bounding box and then extruding it using a point attractor. Let me know if you have any questions, and let's go ahead and jump right in. So to start, we need to create a point. So I'll go here to construct point. This will give us a point that's parametric in our 0, 0, 0. The other thing I like to do is bring in a point component because sometimes I would like to move the location of this point, and so I can just go to set one point and pick one here instead of Rhino. Now what we need to do is to create a series of points here. So I'll go here to the move component, and we want to move this point. So we'll plug that into the geometry, and we want to move it in the X direction. So I'll bring in the X unit, and notice that I can plug in a value, say 15. So this will move this point by 15 using this component. Now notice that we can only do that once, right? And if I wanted to add another one, I would have to create this and then say another point here, right? So it makes it tricky because this only gives us one number. To fix that, we can bring in the component called series, and this will allow us to say, okay, I want 10. This will go in the count. I want it to step by 15. And so it'll create 10 points. So I'll plug this into the factor. So now, as you can see, using this series component, we can create 10 points that step by 15. And so it'll create all of these 10 numbers in a series starting 0, 15, 30, stepping by 15. So this is how we can create a series of numbers, more than one point, using one component into the move component. This will become our distance between. So this is distance between points. We can group this one, and for this one, this is going to be number of points. And we'll group this together. And the reason why I group it is because I know that when I zoom out, I know that these are sliders that I can change. I can also change the color by right clicking and then changing this and making that your default. So right now I have green as my default. Now that we have all of these points, notice that there's also a start. That one I don't really use as much, but it can be useful in certain instances. Like, we'll take our original points and we will hide them. And our start point, it's at 0. So as you can see here on the output, it starts at 0, 8, 16. But we can also make it start at 8. And this will actually move that initial point by 8. And so as you can see, now our points start at 8. So this will give us the ability to change our start point. And we can bring in a slider, and we can use this as our initial gap. So with that being said, let's organize this. What I like to do is select it, use this arrow, align some to the left, and now I can use this one, and it'll center all of those. Now that we have all of these points, we need to rotate them using a series component because we want also a stepping amount for the rotation. So let's bring back our original point, which is going to be this one. And now we want to rotate all of these points using this as our center point. So I'll double click here and go to rotate. And when you go to rotate, there's actually a few different components. We're just going to do rotate an object on a plane. Our plane is going to be this point. And technically it's a point, so it won't be a plane, but that's going to locate the plane. We can also bring in a y-x plane, or let's see, x-y plane, and we can use this component as our input. Now let's plug in our geometry. But notice that it rotates all of them at once. And we have the same issue that we had at the beginning where we just had the ability to move it by one. We need to be able to step it also. So what I'll do is on this angle, first things first is let's create a slider. We can plug this here. And notice that the way that it does the angle, it doesn't do it in degrees. So I'll right click on here, go to degrees. Now, as you can see, we can change this using degrees. But we're doing it all at the same time. So let's go ahead and change that to being stepped by 45. So I'll double click here and go to a series component. And first thing that I need to do is make sure that the points are matching. So I'll go to number of points, plug that into here. So they're both, so we have the same amount of points in rotations. I can use the 45 for the step. And we can plug this now into the series. So as you can see now what it's doing is it's rotating these points by 45 degrees. So let me decrease it so you can see it in a simpler way. So all of these points get rotated relative to the center point, stepping by 3 degrees. Let's actually change this to 5. Now let's connect. So I will disable the preview on these. And now let's connect these points to the initial point. So I'll go to a line component and let's plug in our points as the start point. We'll use this as our end point. I want to do this to illustrate what it's doing with the angles. So as you can see, all of these angles here are going to be exactly the same. So we're stepping by 5, and we can increase that number. But the only thing that's changing here is the distance that they were here, and that's what creates a spiral. So let's change this to rotation, step. The other thing is we have the number of points maxed at 10. So I'll double click here and change our max number to 100. And as you can see, we can just continue on adding points to the outside. And we can have a really large number if we wanted to, and just continue on. Right, and also the distance in between, it's going to determine the size of that. The initial gap will determine this portion. And our rotation will determine our pattern, really. And if we go here to a really small rotation, you see that we can create this really smooth, like shell-like spiral. So now with that, let's go ahead and turn this into a pattern. So I'll take, let's see here. We're going to take all of these points and turn it, use it as our points to use our Voronoi pattern. So let's take these lines, and I'm just going to delete them. That was just mostly to illustrate that the angles are the same for all of them. So let's delete that. And let's come back to our points here. Now I've created a bunch of points. Let's bring that back down to a lower number. And when we lower that number, we actually have to increase our rotation step. So I'll go to 15. And now that we have these points back, let's bring in the Voronoi component. So this is going to be a Voronoi 2D. So Voronoi, planar Voronoi diagram. And so we'll use this geometry, we'll plug that into the points, and automatically we've created a pattern just by plugging it into this. What Voronoi does is it takes these points and it calculates the midpoint and then the perpendicular and where those intersect. So this is a really efficient way to subdivide any surface using points, and it's actually used in nature all the time. So if you keep an eye out, you'll see this is actually the most efficient way to subdivide any surface using random patterns. But with that being said, let's take these cells and let's now crop it. So as you can see, we have a boundary. For this boundary, we can use a rectangle. So let's go to our initial point and let's create a rectangle off of this. So I'll go to a rectangle component. And I'll plug in this point or this plane. Actually, we can plug this plane into it. And in the X and in the Y, we can plug in some values. So let's just say 100. This way we can keep it as a box. It's kind of small. And here's what happens is when you create a rectangle, it actually starts at the bottom left. And that's a bit of a bummer, and you'll see why in a second. Because we need to actually move this and center it so we can have the pattern be symmetrical and start in the center. So we need to move this. And so we move this rectangle to be centered. We need to move it halfway in the opposite direction. So I'll move 100, or let's see here, in the X direction. And actually it's going to be negative. So whatever amount we move, it's going to be negative and half. So divided by 2. And when I do divided by 2, it gives me an empty value for A and B as 2. And this moves it halfway in the X direction. Now we have to do the same thing in the Y direction. So we can actually do a vector XYZ, and we can do X and Y, and this will move it X and Y 100, but it'll do it negative and it'll do half of that. So it actually ends up centering this rectangle. And that's why I said it's a bit of a bummer that there's not, maybe there is in Rhino 7, but there's not a component that starts a rectangle from the center point. Let's create the slider and change it to like 500. And now we can use this as our cropping tool. So after all of these steps, which are kind of cool to understand, we can use this geometry to plug into the boundary here. Now this becomes our bounding box that we can change. And if we don't like the way our pattern's looking, it could be that the distance is a little bit too big here and we don't have enough points. And also, you can change the angle. So this angle is also going to determine a lot of the pattern. So let's pick a cool one here. 35 looks good. I'll just clean some of this stuff up here. The important thing, one of the important things is to make sure that your number of points for the rotation and for the move are the same. Let's take this and disable preview. And sometimes the construction plane in Rhino kind of gets in the way, so I'll go to display options and hide that. And even change the background to be white. Let's see here. Cool, now let's take this and create some surfaces. So I'll do boundary surfaces. But let's actually offset curve. And let's go to, now since we offset this curve to the outside, we actually want to do it to the inside. This is where we bring in a negative component, and we can just say like 1.5. So we're moving this, we're offsetting this negative 1.5. There are some cases in which it just gives us issues, right? There's going to be, and that's because sometimes we need to plug in that plane here. If this fixes our issue. Kind of does, but it kind of doesn't. Let's see here. And it could be the amount, like the lower the number, it'll actually work. And it has to do with some of these segments. Even here, it's not working. So the other option is going to be to scale these down. So I'll bring in an area component. So I can get the exact center point here. And now I can scale that pattern relative to the center point and all of these cells. And I can use a factor. And this time it'll make everything work. Why? Because it's scaling it down. It's not really offsetting anything. So it won't have any issues with those small segments. Let's go to factor. It's going to be between 0 and 1 to make it smaller. And to make it bigger, it's going to be between 1 and 2. Or 1 and whatever number. So let's go here, 0 less than 1.000. Let's go to 0.9 or 0.88. Now let's create a surface on the scaled down geometry rather than these. Now let's go to boundary surfaces. Let's increase the points. And to get a little bit more detail here, we can go to range and actually change the maximum to be maybe like 20. We can always change these, right? So I'll disable the preview on the scale. And with this, we can extrude them. Now what I want to do is actually use a curve attractor or a point attractor to extrude these more, the ones in the middle more than the ones on the outside. So first, I'll go to extrude. Next thing I'll do is plug in the surfaces into the base, and direction, I'll use unit Z. So it's going to extrude everything just one value. And as we've noticed before, that gives us cool results, but when we have this dynamic look, we can create more variety in the design. So let's take this, move it in the Z direction, and this is going to just do 1. What we want to do is change that. So we'll take these center points and create a line between those center points and the initial point. All of these different lengths will determine the length of the shape. So as you can see, I can plug in this line into here and automatically get something working. Now it's doing the opposite where the spiral is lower, and that's because we need to remap the numbers. Let's see here. So as you can see, this is not really the result that we're trying to get, and there are some issues here. So let's go ahead and actually go back here to the centroid, and we need to flatten this point. We also need to remap all of these lengths so we can have it be the opposite. So let's do that. Let's take this extrusion, let's remove this, and let's take all of these numbers. So we can take all of these lengths and we'll do remap numbers, because all of these lines are going to have a length. So I'll go to length, and this length will be put into the original values. We also need, for this component, remap numbers, we also need bounds, which will give us our biggest and smallest number. And that goes into the source, and target is going to be construct domain. This way we can pick our biggest and smallest number. So we can say 3.5. As you can see, now we have 210 remap numbers, and we also have, but we only have 189 surfaces. So that's one of the issues that happens, is not all of these are going to have a value. Let's see if we can change that by increasing this number a little bit. 210, 189. So let's see what happens when we plug in these map numbers. These are going to be really small numbers. So let's see, change them out here. Oh, this needs to go into this one. Oh, I forgot to plug that in. So as you can see, they will start to spiral up. Now, some of these are having some issues, and that has to do with the number of points that we have. So we have 210 cells, but for some reason, we only have here 210 values, 210 values, but at the end, under the surfaces, we only have 189. So let's plug in this into the base. So as the further out they get, the smaller they get. So this actually gives us a better result, although it is giving us some issues here. So let's continue on and just cap these. So I'll go to cap holes. And although it's giving us an issue here, and it probably has to do with a lot of the pattern being really tiny here, and so we can probably fix some of those issues, but for the most part, this will give us the result that we want. So I'll go ahead and middle click and bake. This is going to be max number, and then min. And sometimes you don't want this at 0. Maybe that's the issue. I think that's what it is. This number wants to not be at 0. It wants to be somewhere more than 1. So I think that fixed that issue. And let's actually take this, delete it, and let's bake it again. So let's give this smallest number a little bit more. And I'll go and create a new layer here. Call this spiral steps. Make that my current layer, and I'll go to middle click and then bake. Let me change this scale factor. crop size. So I'll go ahead and save this, and then we can edit this a little bit to see what it looks like. Okay, now I'll go to this don't draw preview the geometry in Rhino, and I'll go to Rhino mode. Let's go to shaded, and let's also go to rendered mode. So that's what that pattern looks like here in 3D. We can definitely apply some patterns and render it and see what that looks like, but the idea for this tutorial was mostly to show you how to create that pattern. It's pretty straightforward. It seems complicated, but all it is 2 different steps: stepping in between points and stepping rotation. Then we did offset or scale, so we can scale down the pattern, and then we use a point attractor in the center, so we can use that as the largest point, and we remap the numbers. If you have any questions, make sure to let me know. If you have ideas for future videos or you want something explained further, also let me know. Thank you for watching, and I hope to see you next time.